Hi, this is Nathan Tintle. In this Learning Goal video, we're going to answer the question, when will simulation and theory yield different answers? And we'll talk about this using the Halloween Treats data. Theory says that in some cases we can predict the shape, center, and standard deviation of the null distribution without doing simulation, as long as certain validity conditions are met. That is, at least 10 successes and 10 failures occur in our data. We can predict that the null distribution will take a bell-shaped curve centered at the long-run null probability and have a standard deviation equal to the square root of pi times 1 minus pi over n. Because the validity conditions are met, we know the following. For the Halloween Treats data, there are at least 10 successes and 10 failures, so the standard deviations of the null distributions from theory and simulation will essentially be the same. You can see that on these two graphs. The standard deviation is 0.03 in both cases. Similarly, the shape of the null distribution will be similar in both cases, bell-shaped curves. The center of the null distribution will be the same in both cases. They'll both be centered at 0.5. For this reason, the standardized z-statistic that we get from simulation or from theory will essentially be the same at 0.77, and similarly, the p-value will be the same in both cases, approximately 0.44. But what if the validity conditions are not met? In the rock, paper, scissors study we talked about, your friend chose scissors 2 out of 12 times. Because the friend only chose scissors 2 times, that's less than 10. Our validity condition is not met. In this case, we are less sure that the simulated null distribution will be bell-shaped with the standard deviation as predicted. And so we're less sure that the z-statistic and the p-value will be similar from simulation and theory. So, if validity conditions are not met, you should use simulation. There's no guarantee in these cases that theory-based predictions will be accurate. So why should you use the theory-based approach at all? This is and has been the standard approach for over 100 years and is still accurate in most cases.